Alright, section 2.6 talks about shifting, reflecting, and stretching and shrinking, as well as even and odd functions. First, a vertical shift is taking a known function, f, and bumping it up c units or dropping it c units. It moves the whole function up or it moves it down. Horizontal shift is where you take a known function and you add or subtract a number on the inside of the function. That will move it left-right, but again it moves it the opposite way you would think. You would think subtracting would move it left because left is negative on the number line, but no, it moves it to the right. And if you think add c, you would think moves it to the right. No, it moves it to the left. Now reflecting, there's two reflections. There's putting a negative in front will reflect it on the x-axis, above to below and below to above. And putting a negative on the inside moves it on the y-axis from left to right and right to left. Vertical shift, if you multiply it by a number, it will stretch it or shrink it. Well, if it's greater than 1, it will stretch it. It will make it go. For example, if you multiply it by 5, it makes it 5 times higher and 5 times lower. If you multiply it by a number between 0 and 1, like a half, it'll make it go up half as high and half as low. Makes sense doing the vertical shifting. Horizontal shifting is the opposite way you would think. If you multiply by a number on the inside of a known function, if the number is greater than 1, like 5, you would think it would make it 5 times as wide. No, it makes it 1/5 as wide. It actually shrinks it to 1/5 of what it was. And then what about 1/2? If you got 1/2 in there, you would think it would make it half as wide. No, you flip the 1/2 and it's twice as wide in both directions. An even function is a function where if you plug in negative x into the function, you get the original function back. Classic example is x squared. An odd function is a function where if you plug in negative x into the function, you get negative f of x, which is classic function is x cubed. So let's do some problems here. 2.6 question 1 says the graph of y equals f of x plus 3 is obtained from the graph of y equals f of x by shifting upward 3 units. The graph of y equals f of x plus 3, f of x plus 3 is obtained by shifting to the left 3 units. And this one was f of x plus 3. Number 2 says y equals f of x minus 3. That's going to move it down 3. And f of x subtract 3 is going to move it to the right 3. And number 3 says negative f of x. That moves it, reflects it on the x-axis. And then f of negative x reflects it on the y-axis. And number 9 says, tell me what happens to this function 1/4 f of negative x. Well, first the negative x is going to reflect it on the y-axis, and then it's going to shrink vertically by 1/4. 1/4 is high and 1/4 is low. This one takes a known function and first the negative reflects it about the x-axis, and the 5 makes it go 5 times as high and 5 times as low. It stretches it 5 times. 10, the negative is going to reflect it on the x-axis, and the 6 is going to stretch it 6 times as high and 6 times as low. 2/3 f of negative x, this negative on the inside is going to reflect it on the y-axis, and the 2/3 means it only goes 2/3 as high and 2/3 as low. So let's look at an actual question here. -2 square root x plus 4 plus 3. So you build it up slowly. You first start with the basic function square root. So here's your square root, and you start with some points that you already know. For square root of x we know 0, 0, 1, 1, 4, 2. Square root of 4 is 2. Square root of 1 is 1. Square root of 0 is 0. So 0, 1, 1, 4, 2. Okay, and then square root of x plus 4 is going to move it to the left 4 units. So this point here moves over 4. This point here moves over 4. This point here moves over 4. And now you graph this is the square root of x plus 4. Where this one's just the square root. Now number 3, reflection on the x-axis, that's dealing with a negative. So now that's negative square root of x plus 4. Now how did I get that? I took number 2 and I reflected it. So this point that was 1 above is now 1 below. This point that's 2 above is now 2 below. And I connect my dots and I got that one, the third graph there. Negative square root x plus 4. Now let's deal with the 2. Now the 2 is going to make it 2 times as high and 2 times as low. Well, if this one goes to minus 1, now it goes to minus 2. If this one goes to minus 2, now it goes to minus 4. If this one is at 0, well, 0 times 2 is still 0, so 0. So here's your graph. It's now going down twice as fast as it was before, because you multiplied it by 2. If it was above, it would go up twice as fast. Alright, and then finally add 3. The add 3 takes your known function that you got, number 4 there, and bumps it up 3 units. So this point here goes up 3. This point here goes up 3. This point here goes up 3. So there's your answer, number 5. So again, what did we do? We took a known function, square root. We moved it to the left 4. We reflected it down. We made it go twice as high and twice as low. And then we took the entire graph and bumped it up 3 units. 46, absolute value. So you start with the absolute value, which is here, number 1. Absolute value starts at 0, 0, 1, 1, 2, 2, 3, 3. Same thing for the negatives. Okay? And then we're going to move it to the right 2 units, and that's going to become, this one's absolute value of x. This one's going to become absolute value of x minus 2. Notice if you subtract 2, it goes positive 2. So everything moved over 2 units. Okay? And then a negative out in front flips it on the x-axis, so that's minus absolute value of x minus 2. So now it's this number 3 here. Okay, and then the 1/2 is going to shrink it vertically by a half. So instead of it going to minus 2, it only goes to minus 1. Instead of going to minus 4, it only goes to minus 2. Everything goes half as much. So instead of going this far down, it only goes half as much. Okay, so there's your 4 is minus 1/2 absolute value of x minus 2. And then finally add 1. This is a positive 1, right? So you're adding 1. And so it takes this number 4 and bumps it up by 1 unit. So minus 1 becomes 0, 0 becomes 1, minus 1 becomes 0, and so on. Everything goes up by 1 unit. 47, 1/2 x plus 2 squared minus 3. It's trying to be x squared, so we start with that. There's your x squared. Then we move it to the left 2 units, and that's x plus 2 squared. Again, positive 2 on the inside moves it to the left 2 units. So this guy moves over 2 units. Again, keep track of some points here. We got 0, 0, 1, 1, 2, 4, 3, 9. So 0, 0 becomes negative 2, 0. 1, 1 becomes negative 1, 1. 2, 4 becomes 0, 4. 3, 9 becomes 1, 9. And the same thing on this side. Everything moves over 2 units. Okay, so then you shrink it vertically by a half because you're multiplying by a half there. So this is 1/2 parentheses x plus 2 squared. So 1/2 says Instead of going up to 1, it goes up to a half. Instead of going up to 4, it goes up to 2. Instead of going up to 9, it goes to 4.5. So it goes up half as fast, and that's your 3. Now the final one is down 4. So you take this function that you have is 3, and you drop every point by 4 units. So 0 becomes minus 4, a half becomes minus 3.5, 2 becomes minus 2, 4.5 becomes a half. Okay? And so, or 4.5 becomes 1.5. Everything drops by 3 units. .48, you start with the square root, and square root has 0, 0, 1, 1, 4, 2. You want to pick specific points on your graph so that you know how to shift it properly. First thing is we're going to graph square root of x minus 1. That's going to move it to the right 1 unit. So 0, 0 becomes 1, 0. 1, 1 becomes 2, 1. 4, 2 becomes 5, 2. Everything moves over 1 unit. Okay, now 2 is going to make it twice as high and twice as low. So this is 2 square root x minus 1. So where it went up to 1, it now goes up to 2. Where it went up to 2, it now goes up to, where it went up to 2, it now goes up to 4. Here it's at 0, so 0 times 2 is still 0. So 0 stays 0, 1 becomes 2, 2 becomes 4. So there's your 2 square root of x minus 1. And now what is the last part? Adding 3. Everything goes up 3 units. So 0, 0 is, or 1, 0 is now 1, 3. 2, 2 is now 2, 5. And 5, 4 is now 5, 8, or 5, 7. 5, 4 is now 5, 7. The entire graph moved up 3 units. 49. We start with the square root. Go to the left 4 units. Again, adding 4 on the inside moves it to the left 4. And then 1/2 square root x plus 4. It's going to make it go up half as high. So here 0 moves up nothing, and 1 only goes to 1/2. 2 only goes up to 1. So it only goes up half as fast, and that makes sense because you're multiplying it by a half. And then subtract 3, it drops the entire graph down 3 units. So here goes down minus 3, here a half goes down to minus 2.5, here 1 goes down to minus 2. And so there's your final graph as the fourth one. 51 says take the function f of x and move it up 4 units. Find the graph. So that's x squared plus 4. It says take the function square root and shift it down 4. So that's square root of x subtract 4. 57 says take the fourth root, reflect it about the y-axis, and shift up 1. So reflect about the y means you put a negative on the inside, and up 1 means you add 1. X squared, move 2 units to the left and reflect about the x-axis. So 2 units to the left is add 2 on the inside. Reflecting on the x-axis is putting a negative out in front. And 61, they say find the transformation. If you look at the graph they give you, you'll see that it moves it to the right 2 units, so you just subtract 2 on the inside. And for 62, if you look in the book, you'll see that it moves it up 3 units, so you just add 3.